Hey guys, Mr. Backerberg here. In this video we're going to be running through the review for test number 9. Taking a look at problem number 1, we're given a cotangent value and a sine value. We want to go through and find the values for our other 4 trig functions. 2 of them should be pretty easy to find by just doing reciprocals. So since we're given a cotangent value of 24 over 7, that means that the tangent of theta is going to be 7 over 24. And since we have the sine being negative 7 over 25, then we can get the cosecant of theta to be 25 over negative 7. Next thing we need to find is our cosine value. So I'm going to use one of our Pythagorean identities. We've got an identity that says the sine squared plus cosine squared equals 1. So I'm going to use that sine squared value, that negative 7 over 25. We're going to square that plus the cosine squared of theta equals 1. Now squaring that fraction, we're going to have to square the top and the bottom. So we get 49 over 625 plus the cosine squared of theta equals 1. I'm going to subtract that fraction over to the right-hand side. So then we get the cosine squared of theta equals 1 minus 49 over 625. We're going to have to get common denominators in order to subtract those things. So 1 is like having 625 over 625. So then when we do that subtraction, we end up getting 576 over 625. So that's our cosine squared value. In order to get rid of the squared, we're going to have to square root each side. So we get the cosine of theta equals plus or minus 24 over 25. Now we need to decide if this is going to be positive or negative. So if we look at what we were given, we had a negative sine value and a positive tangent value. So that means we're going to be in quadrant 3, and cosines are negative in the 3rd quadrant. So that cosine value is going to be negative 24 over 25. And then we can take that and get our secant value by doing the reciprocal. So we get 25 over negative 24 as our answer for the secant. In problem number 2, we're using some of our identities to simplify down this fraction, tangent over secant squared minus 1. First thing I see on bottom is we can use a Pythagorean identity to replace that secant squared minus 1. So we've got tangent squared of theta over Pythagorean identity. This ends up being tangent squared of theta. Then we can do a little canceling. This tangent on top will cancel out one of those tangents on bottom. So we get 1 over the tangent of theta. But we're not quite done yet because we don't want to leave our answers as fractions if we can avoid it. So 1 over the tangent is the same thing as the cotangent of theta. For problem number 3, we're asked to do a little factoring before we simplify down. And since factoring is the very first word, that's what I'm going to look to do first. We've got a cotangent squared showing up in both of our terms. So we're going to pull that out as a GCF. So we've got cotangent squared of theta times 1 minus cosine squared of theta. Now 1 minus cosine squared, we can use a Pythagorean identity to make that sine squared of theta. But I'm also going to make a change with this cotangent squared. I know that cotangent is cosine over sine. Since this is squared, when we use that quotient identity, we have to make this cosine squared over sine squared. And then if we look at our fractions, we've got a sine squared on top and on bottom, so those things will cancel each other out. So then we've got just the cosine squared of theta left over. Taking a look at number 4, we're given a couple of fractions and asked to add them together and then simplify down. Since we're adding fractions, what we're going to need are common denominators. So this is a case where we're going to multiply each fraction by the other one's denominator. So on the left, we're going to multiply by 1 plus cosine on top and bottom. And on the right-hand fraction, we're going to multiply by 1 minus cosine on top and on bottom. So if we take a look at what we've got, taking the 1 plus the cosine on top times 1, we just get 1 plus the cosine of theta, plus taking 1 times 1 minus cosine, well, we just get 1 minus cosine of theta. And then on bottom, if we distribute and FOIL all of this stuff together, since we're multiplying conjugates together, the middle terms will end up canceling out. So all we'll have left over on bottom is 1 minus cosine squared. Now on top we can combine like terms. We've got a positive cosine and a negative cosine, so those will cancel each other out. and we've got 1 plus 1, so I guess we've got 2 left over on top. On bottom, we can use a Pythagorean identity to replace that with sine squared of theta. So now we've got 2 over sine squared, but having 2 over sine squared is really like 2 times 1 over sine squared. And just like we mentioned earlier, we don't want to leave our answers as fractions if we can avoid it. So I'm going to use a reciprocal identity to make that 1 over sine squared into the cosecant squared of theta. Taking a look at problem number 5, we're asked to verify this identity. So we've got the cosine of theta times tangent of theta plus cotangent of theta equals the cosecant of theta. Now, typically, one thing we might want to do is to change things into sines and cosines. So what I'm going to do is work on the left-hand side and change the tangent and cotangent into things that have sines and cosines in them using quotient identities. So we've got the cosine of theta times tangent is sine over cosine, plus cotangent is cosine over sine. Now what I'm going to do is I'm going to take this cosine on the outside and distribute it into the parentheses. If we take cosine times the sine over cosine, the cosines will cancel out and we'll just have sine of theta over 1, plus if we take the cosine times cosine over sine, well, cosine times cosine is cosine squared over sine of theta. Now, since we're adding fractions, we want to get common denominators. So on the left-hand side, we're going to multiply that fraction on top and bottom by the sine. So now we've got sine squared of theta plus cosine squared of theta all over sine of theta. Now we can use a Pythagorean identity on top. Sine squared plus cosine squared is just 1, so we get 1 over the sine of theta. And 1 over the sine of theta, reciprocal identity, that is the cosecant of theta, and that's what we wanted to show. We wanted to get the cosecant of theta, so we're done with this one. If we take a look at problem number 6, we're solving the equation tangent cubed of theta equals 3 tangent of theta, and we're asked to stay on the interval from 0 to 2 pi. So what I'm going to do first is I'm going to subtract that 3 tangent of theta over to the left-hand side. So then our equation says tangent cubed of theta minus 3 tangent of theta equals 0. Now on the left-hand side, we can do a little Gcf factoring. We can factor out a tangent of theta. So then on the inside of our parentheses, we'll have tangent squared of theta minus 3 equals 0. Now we're going to use our zero product property to split this up. So we're going to take the tangent of theta equals 0 and the tangent squared of theta minus 3 equals 0. I'm going to work on solving this first one. Tangent of theta equals 0. We're going to have to use an inverse tangent, so theta equals the inverse tangent of 0. And now we're looking at the unit circle to try to figure out at what angles does a tangent value of 0 happen. So we have to think about how these tangent values are made. Tangents are y over x. So if we get 0 as an answer, that means the y value on top has to be 0. So if we're looking at our unit circle for where the y value is 0, that happens at the angle 0 and at pi. Now if we look at this other one, first thing I'm going to do is add that 3 over, so we get the tangent squared of theta equals 3. Then if we square root both sides, we'll have the tangent of theta equals plus or minus the square root of 3. We're going to do the inverse, so theta equals the inverse tangent of plus or minus root 3. Now, just looking for root 3 might be a little bit difficult. So what I'm going to do is, again, I'm going to think about how these fractions are made. Tangents are y over x, and I'm going to build this fraction up a little bit. So having root 3 is like having root 3 over 1, and then if we think about most of those unit circle values, they all have like an over 2 in them. So really what we're looking for is a y value of root 3 over 2 and an x value of 1/2. Signs aren't going to matter because we're looking at positives and at negatives. So if we're looking for y values of either positive root 3 over 2 or negative root 3 over 2 and x values of 1/2 or negative 1/2, then that's going to happen at the pi over 3 family of angles. So for this one, we'll have theta equals pi over 3, 2 pi over 3, 4 pi over 3, and also 5 pi over 3. So those 6 angles are our answers for this one. We don't have to add anything extra on the end because we were told to keep our angles between 0 and 2 pi. So we don't want to add any of those coterminal angles on for this one. If we take a look at number 7, 2 cosine squared of theta plus the cosine of theta equals 1. First thing I'm going to do is subtract that 1 over, so we get 2 cosine squared of theta plus cosine of theta minus 1 equals 0. Now we can actually do some factoring on the left-hand side. This is like unfoiling. We're going to need 2 cosine of theta minus 1 and cosine of theta plus 1 equals 0. Then we can use our zero product property to split this up. So 2 cosine of theta minus 1 equals 0, and cosine of theta plus 1 equals 0. I'm going to work on solving this one on the left first. I'm going to add the 1 over and divide by the 2, so we get the cosine of theta equals 1/2. And then if we do the inverse cosine, we get theta equals the inverse cosine of 1/2. And if we're checking the unit circle for where that happens, whereas the x value or the cosine value 1/2, that'll happen at the angle pi over 3 and also 5 pi over 3. Now if we look at this other one, cosine of theta plus 1 equals 0, I'm going to subtract the 1 over, so we get the cosine of theta equals -1, and then if we do our inverse, we get theta equals the inverse cosine of -1, and that happens at the angle pi. Now we're not quite done with these angles because we weren't given that interval from 0 to 2 pi, so we do need to account for all of the coterminal angles. So when we have that pi over 3, we're going to have to add 2 pi n, and do the same thing to 5 pi over 3, add the 2 pi n, and do the same thing with pi. We're going to add the 2 pi n on the end of there. So that's our final answer, those angles with the coterminal angles accounted for on the end. In problem number 8, we've got 4 sine squared minus 3 equals 0. I'm going to add the 3 over and divide by the 4, so we get the sine squared of theta equals 3/4. Now if we square root each side, we end up with the sine of theta equals plus or minus. Now when we're square rooting a fraction, we're going to square root the top and the bottom. So on top we get root 3, and on bottom we get 2. Now if we do the inverse, then we get theta equals the inverse sine of plus or minus root 3 over 2. Sine means we're looking at y values, so we're trying to figure out where the y values are either positive root 3 over 2 or negative root 3 over 2. One of those happens at the angle pi over 3. And I'm going to add the 2 pi n right away so we don't forget to do that later on. We'll also have 2 pi over 3 plus 2 pi n. We'll have 4 pi over 3 plus 2 pi n. And lastly, we'll have 5 pi over 3 plus 2 pi n. In number 9, we're asked to use our product to sum formulas in order to write this as either a sum or a difference. So we've got the cosine of 2x times the cosine of 6x. So if we look at our formulas, we've got a cosine times a cosine. So we're going to go 1/2 times cosine of, subtract the two angles, so 2x minus 6x, plus the cosine of, add the two angles together, so 2x plus 6x. Then we can do a little bit of simplifying. 2x minus 6x, we get the cosine of -4x. And on the back end, if we take 2x plus 6x, we get the cosine of 8x. Remember, we've still got this 1/2 hanging out in front. There really isn't much more that we can do with this. We could distribute the 1/2 in, so then it would be 1/2 cosine of -4x plus 1/2 cosine of 8x. We don't have to do that, though. We can just leave this as our answer. Number 10, we're using sum to product formulas in order to rewrite this sum as a product, so a multiplication problem. So we've got a sine of 3x minus a sine of x, so sine minus sine. So we're going to go 2 cosine of, add the two angles together, so 3x plus x all over 2, times the sine of, now we're going to subtract the angles, 3x minus x all over 2. Now we can simplify this down. So if we take 3x plus x, that's 4x over 2. So we've got 2 cosine of that fraction times the sine of, subtracting these, we get 2x over 2. And we can do a little canceling. On the end, 2x divided by 2, those 2's will cancel out. So on the end, we'll just get sine of x. In the middle, 4x divided by 2 is just going to be 2x. So it'll be 2 cosine of 2x times the sine of x as our final answer. Taking a look at problem number 11, we're asked to evaluate the sine, cosine, and tangent of a 255-degree angle. Now there's multiple different ways that we can break down 255 degrees. I prefer using sums, so I'm going to break this down into 210 plus 45. So 210 will be my u value and 45 will be my v value. So then if we go with the sine, let's start with that one. We're doing a sine sum. So we're going to do the sine of u, which is 210, times the cosine of v, which is 45, plus the cosine of 210 times the sine of 45. Now if we start pulling values off of the unit circle, the sine of 210 is negative 1/2 times the cosine of 45 is root 2 over 2, plus cosine of 210 is negative root 3 over 2 times the sine of 45, which is root 2 over 2. Now we can multiply these together. Negative 1/2 times root 2 over 2, we're going to get negative root 2 over 4, plus negative root 3 over 2 times root 2 over 2, we're going to get negative root 6 over 4. And then since our fractions already have common denominators, we can go ahead and put these together. So we get negative root 2 minus root 6 all over 4 as our answer for the sine. Now if we're doing the cosine sum formula says we're going to do the cosine of 210 times the cosine of 45 minus the sine of 210 times the sine of 45. So again, we're just pulling those values off of the unit circle. Cosine of 210 is negative root 3 over 2 times the cosine of 45, which is root 2 over 2, minus sine of 210 is negative 1/2 times root 2 over 2. So if we multiply these together, we get negative root 6 over 4. Now this is a double negative, so I'm just going to turn it into addition. So plus root 2 over 4. And then since our fractions have common denominators, we can put them together to get negative root 6 plus root 2 all over 4. Lastly, we need to do the tangent. So if we're doing the tangent sum formula, we're going to do the tangent of 210 plus the tangent of 45 all over 1 minus the tangent of 210 times the tangent of 45. So on top, the tangent of 210 is root 3 over 3 plus the tangent of 45 is 1 all over 1 minus tangent of 210 is root 3 over 3 and tangent of 45 is 1. Now we're going to do some simplifying. Taking this root 3 over 3 times 1 on the end, we don't really need to put the times 1 in there, so I'm just going to erase that to start cleaning this up a little bit. Now if we look at our fractions, we've got little fractions inside of this big fraction, and our little fractions have denominators of 3. So what I'm going to do is I'm going to multiply the top and bottom of this fraction by 3 in order to cancel out some of those extra fractions. So if we take 3 times root 3 over 3, those 3's will cancel and we'll just have root 3. 3 times 1 is just going to be 3. And then on bottom, 3 times 1 is 3 minus, again, these 3's will cancel out, so we'll just have root 3. Now typically we don't like to leave our answers with radicals in the denominator, so we are going to multiply by the conjugate. So we're going to have to multiply top and bottom by 3 plus root 3. On top we're going to do some foiling, so 3 times root 3 is 3 root 3. 3 times 3 is 9. Root 3 times root 3 is 3, and root 3 times 3 is 3 root 3. So that's the top of our fraction. On the bottom of our fraction, since these are conjugates, the middle terms will end up canceling out. So if we take 3 times 3, that'll be 9. And negative root 3 times positive root 3 will be minus 3. Now I'm going to clean this up. So on top we can combine like terms. So we've got 9 plus 3, which is 12, plus 3 root 3 plus 3 root 3 is 6 root 3. And on the bottom of our fraction, we're just going to have 6. Now, since we have 2 terms on top and 1 term on bottom, we can split this up. So 12 divided by 6 is 2, plus 6 root 3 divided by 6. The 6's cancel out, so we just get root 3. So there's our final answer, 2 plus root 3. Taking a look at number 12, we're asked to find the exact values of the sine of 2u, cosine of 2u, and the tangent of 2u using our double angle formulas. So we're told that the sine of u is 24 over 25, and that our angle u is somewhere between pi over 2 and pi. So I'm going to use that information to draw out a picture. Since our angle is between pi over 2 and pi, that means it has to be in the second quadrant. Now our sine gives us the opposite side and the hypotenuse. So we can label this opposite side as 24, and our hypotenuse is 25. Now we're going to use the Pythagorean Theorem in order to find our missing side. It ends up being 7, but since it's coming left, it's actually negative 7. So this is our picture that we're going to use as we're running through these formulas. So the sine of 2u, if we look at our formula on your formula sheet, it says 2 times the sine of u times the cosine of u. So I'm going to start filling in some information. So we've got 2 times. We can look at what the sine of u is. That's our 24 over 25. And then if we do the cosine of u, we'll have to look at our picture. Cosine is adjacent over hypotenuse. That's going to be negative 7 over 25. Now what we can do is we can take all of these fractions and multiply them together. I'm going to put the 2 over 1 to make it easier to see where the fractions are. So if we take 2 times 24 times negative 7, we're going to end up getting negative 336. And then on bottom, if we take 1 times 25, we get 625. There's not any reducing that we can do with that, so that's just our answer. Next, if we look at the cosine of 2u, there's a bunch of different formulas that we can use. I'm going to use the one that says 1 minus 2 sine squared. So it goes 1 minus 2 times, we need our sine value, which is 24 over 25, and we have to square that. Now if we work on simplifying this down, we've got 1 minus 2 times. Now if we square this fraction, we're going to get 576 over 625. And then multiplying by the 2, remember the 2 is like over 1, so 2 times 576 gives us 1,152 all over 625, and this is still 1 minus. So if we're going to subtract these fractions, what we're going to need are common denominators. So this 1 is going to turn into 625 over 625. And then if we carry out that subtraction, we end up getting negative 527 over 625. And again, no reducing that we can do there, so that's our final answer. Last one we've got is the tangent of 2u. So the formula goes 2 times the tangent of u. So we need to look at our picture. Tangent is opposite over adjacent, so 24 over negative 7, all over 1 minus the tangent, which we just found, 24 over negative 7, but we need to square that value this time. So now on top, we're going to do our multiplying. So 2 times 24 is 48 over negative 7. On bottom, we're going to square this fraction, so 1 minus 576 over 49. With that 1 and the subtraction on the bottom, we're going to need common denominators with those. So that 1 is like 49 over 49. So if we subtract those things on the bottom, then we end up getting negative 527 over 49. And on top, we've still got 48 over negative 7. Now, one thing I notice is that we've got a negative on top and on bottom, so I'm going to cancel those out and make them positive. Now, I don't like having fractions inside of fractions, so I'm going to multiply top and bottom by 49. On bottom, what that'll do is it'll cancel out the divided by 49, so then the bottom of our fraction will just be 527. On top, if we take 48 divided by 7 and then multiply that by 49, we're going to get 336. So that'll be our answer for the tangent because there's no reducing that we can do there. 336 over 527. In number 13, last thing we need to do is look at using our half angle formulas to find the values of the sine, cosine, and tangent of the angle pi over 12. Now this pi over 12 is half of a unit circle angle. So in order to figure out the u value that we're going to use as we're setting up these sine, cosine, and tangents, this u over 2 is pi over 12. So we're going to work backwards to kind of figure out what u is. So if we multiply both sides by 2, then the u value that we're going to be using as we're setting up these formulas is going to be pi over 6. So if we're doing the sine of u over 2, which is pi over 12, then what we're going to do is plus or minus the square root of 1 minus the cosine of our angle u, which we just said was pi over 6, and that's all over 2. Now, what we can do right away is I'm going to take a look at that plus or minus. Since we're in the first quadrant with a pi over 12 angle, signs are positive in the first quadrant, so I'm just going to erase the plus or minus because we're going to be dealing with a positive square root here. Now, if we look at doing the cosine of pi over 6, so we've got the square root of 1 minus. The cosine of pi over 6, if we look at our unit circle, is root 3 over 2. And that's all over 2 still. Now, I don't like having fractions inside a fraction, so I'm going to multiply top and bottom here by 2. Now, on top, we're going to have to distribute the 2, so 2 times 1 is 2, minus, if we take 2 times root 3 over 2, the 2's will cancel out, and we'll just have root 3. And then on bottom, 2 times 2 will be 4. But this is all still underneath a radical. Now, we can simplify down this just a little bit. Since we're square rooting a fraction, we can do the top and bottom individually. The top, there won't be much simplifying that we can do, so that's just going to be the square root of 2 minus root 3. But on bottom, that 4, when we do the square root of it, can turn into just a plain 2. So now that radical is only on the top portion. It's the square root of 2 minus root 3, and there is no longer a radical on the bottom of our fraction. Now, if we're doing the cosine of u over 2, so again, our u over 2 is that pi over 12. We're going to do plus or minus the square root of 1 plus the cosine of pi over 6, since that was our u value that we found earlier, all over 2. Now, just like I did earlier with that sine, since this is in the first quadrant, we don't really have to worry about the plus or minus since this is going to be a positive value. Looking at that cosine of pi over 6, we're going to plug in its value from the unit circle, which is root 3 over 2. And this is all over 2 still, so 1 plus root 3 over 2, all over 2. Similarly to what we did earlier, I don't like to have fractions inside of fractions, so we're going to multiply top and bottom by 2. So now if we distribute that 2 on the top of our fraction, we're going to get 2 plus root 3 all over 4, and this is all still underneath that radical. And again, we can square root the top and the bottom, so on top we get the square root of, and on bottom, when we square root that 4, it just turns into a 2. Last thing we have to do is the tangent of u over 2. So we've got a couple of different formulas that we can use here. I'm going to use the one that says 1 minus the cosine of u, which is pi over 6, over the sine of u. Now we've got two values we need to pull off of the unit circle. 2 plus the cosine of pi over 6 we've been using a lot. That's root 3 over 2. And the sine of pi over 6 is going to be 1/2. Again, I don't like to have fractions inside a fraction, so we're going to multiply top and bottom by 2. If we distribute on top, then 2 times 1 is 2 minus root 3. And on bottom, if we take 2 times 1/2, we just get 1. Since this is a fraction being divided by 1, we don't really need to put the divided by 1 in there, so our final answer that we're going to get is just 2 minus root 3. That's going to be it for this video. Thanks for watching.